Hello, my name is Luke Swanson. This is my SunBurn engineering project. So SunBurn does is it uses a magnifying glass to focus the sunlight into a point, and this point is moved around using stepper motors to burn a pattern onto a piece of wood. To move these stepper motors, I'm using an open source program called LaserGRBL, and this program interfaces from my computer to an ArduinoUno that is running the stepper motors on SunBurn. This stepper motor right here controls the magnifying glass gantry and moves it in the Z axis, so it can move it to the left or the right depending on where the software LaserGRBL tells it to go. The Y axis or the up and down axis is controlled by this stepper motor down there, and together these two stepper motors create the movements to move the point wherever it needs to go. This motor here is moving the platform down, so at this point it will be burning right about here. But since it's not outside, it's not going to be burning because I'm not going to be burning yet. And then this motor here pulls it side to side. In a second it'll get to the point where it's going to the side. So see, so now it's going to the side. And then those two motors combined create any pattern that I want to make. This is the LaserGRBL, so it works by just sending positions to the stepper motors through the Arduino. As you can see, this point is where the point on the piece of wood would be, and this is all the data being sent. To turn the burning point on and off, I'm using a small servo motor that moves this shutter to cover up the hole of the magnifying glass. So this, when I open it up, the sun is able to burn the wood, and when I close it, the sun stops burning because this is blocking the light from getting to the wood. Because the magnifying glass has a set focal length of 200 millimeters and I wanted to use different thicknesses of wood, I designed these two lead screws so I can change the focal position by adjusting these screws. And then I designed and 3D printed this little gauge right here so I can set that on the piece of wood and it'll touch the bottom of the magnifying glass piece, and then I know it's focused correctly. Because I wanted to engrave on wood with different dimensions, I designed these two holders that can slide in and out and are pulled in by two rubber bands. And using these, I can hold any piece of wood up to the limit, of course. So that's how all the engraving bit works, but that couldn't work without being able to track the sun. To track the sun, I'm using 4 photoresistors. Photoresistors output a different analog number depending on how much light is exposed to them, between 0 and 1024. And by reading these numbers using an ArduinoMEGA, I can determine how much light is on each photoresistor. The photoresistors are down here in this, down here. See that this is one right there, right in there, and there's 4 of them in a cross shape with dividers between each one. The reason for the divider between each one is because that way the light is separated and I can create shadows using this piece. So if the sunlight is brighter on this side of the tracker bit, it'll move it this way, and if it's brighter on this side, it'll move it this way, and if it's brighter on the top too, it'll move it up, brighter on the bottom too, moves it down. And so using those 4 sets, it can track the sun to anywhere as long as it's within the limits of my how far I can move the piece. So that's how far down it can go. It can go pretty much straight up. The reason for these shields is to block environmental light from getting in. So if there was light coming in from the side, it would mess up the readings and make it higher than it actually was. So by adding those, I was able to improve the tracking capabilities. So to move the tracker, I'm using two more stepper motors, one down here to rotate the base, and one on the side over here to tilt the whole system. And those are both on big gears. So there's a big gear to a small gear, and then down here is a big gear and a smaller gear that goes inside of a big gear on top of a Lazy Susan. And that's how it rotates and tilts. All of the electronics are housed in this enclosure. So the ArduinoMEGA that controls the sun tracking, the controllers for sun tracking, and the controllers for the stepper motors for the engraving, and then the ArduinoUno for the engraving as well. This switch controls whether the sun tracking is turned on or not. So when I turn on the sun tracking, it is reading the values of the photoresistors, and if they're too low, it holds its position so that it doesn't move. And also if the photoresistors are all equal, it'll hold its position so it doesn't move. Well, it doesn't move as much. It still moves a little bit because of tolerances in the stepper motors. But this LED shows me that this tracking is active, and this LED, which isn't on, would tell me that the sun tracking is running. So when this LED turns on, that means that the photoresistors are above the minimum value and that sun tracking is moving, and it's tracking the sun currently. But if that light is off, that means the photoresistors are below the minimum value and it's just holding in position. The reason I made it to be a minimum value is because when clouds cover the sun, it'll start tracking to the closest, brightest thing, but it'll just get messed up. So by adding that system, I'm able to keep it within its limits. I wrote the program that tracks the sun, and by using all sorts of different functions like a smoothing function and many other pieces, like comparing the averages of the photoresistors, I was able to track the sun accurately for any amount of time, as long as the sun is shining brightly. Everything on this project I designed on Fusion 360. Most of the pieces are 3D printed, all the components that connect, so all these white pieces, all these green pieces, like this mesh stuff was 3D printed. I just printed it without the top or bottom layer, used it in my slicer software, which gave it this cool effect. And then all the wood pieces I cut out, and then everything is held together by washers and bolts and nuts. Here's a time lapse of SunBurn in action. This burn took about 12 minutes, and I'm really happy with how it turned out. Thank you for taking the time to watch this video and learn about my project. I spent a lot of time working on it, and I'm really happy with how it turned out. If you have any questions, I'll try to answer them to the best of my ability in the comments below. Thanks again, and have a great rest of your day.